For this problem we need to find the unknown voltage V1. So the voltage of this node is V1, we know that, and if we call this one to be ground, this one's voltage will be 60 volts, and there is a current dependent voltage source here, so the voltage here will be 60 plus 6I5. So 60 plus 6I5, and I5 is this current. So we know that. First let us try writing a node current equation, that means KCL for this node. So if we do that, let's say all the currents are outgoing, sum of the outgoing currents is 0. So V1 minus 60 is one outgoing current, divided by V1 minus 60 divided by 2, because that's 2. So this is this current. Then the downwards current will be plus V1 over 24, and then plus the current towards which is negative I5, but I will write in terms of V1, so that will be V1 minus 60 plus 6I5 divided by this resistance, which is 3 ohms. So sum of this will be 0. So we can rewrite this one, V1 half plus 1 over 24 plus 1/3, and then this one will be I5 will be, the coefficients of I5 will be 2, so I can just write minus 2, so I can just write minus 2I5 like that, and equals to this one will be 50. So that is equation 1 here. Now we can see that there is a super node here, but instead of going there, we can write actually just the equation of I5. So I5 is the current going in that direction, in this branch. So that will be, of course, 60 plus 6I5, which is the voltage of this node, minus V1 divided by 3. So that becomes 3I5 equals to 60 plus 6I5 minus V1, or V1 minus 3I5 equals to 60. So this is our equation 2. So what we have now, what I have done again, I have just plugged this thing in a linear solver. So we have, if I rewrite, this is V1 half plus 1 over 24 plus 1/3, and then minus 2I5 equals to 50, and here I have V1 minus 3I5, I believe, minus 3I5, sorry, so minus 3I5, let's write like that. So this is becoming minus 3I5, the coefficient, and then plus 60, sorry, that's equals to 60, lot of mistakes, so like equals to 60. So the coefficient here is 1 basically. So once I plug this in a linear solver, what I get, V1 to be 48 volts and I5 to be minus 4 amps. That means I5 is in the opposite direction and the value is 4 amps. So if we just apply determinant method, what would the result would be like this, V1, so I will write half plus 1 over 24 plus 1/3, and this is minus 2, and then 1, this is minus 3, and on the right hand side this will be 50 over 60, 50 and 60 here, sorry, not over, because that's the right hand side, and we want to find V1. So instead of V1's coefficient, I will write that, and then minus 2 minus 3, minus 2 minus 3. So let's try doing that actually. So this is becoming, V1 is in the numerator, it's becoming minus 150, and then plus, because that's minus 120, and here this is, so this one is 0.875 times minus 3, this is 0.875, and then minus 2 times 1, so that's plus 2, so this is becoming 2.625 minus and then plus 2, and in the numerator it is becoming minus 30, so we have V1 is equals to minus 30 over minus 0.625, which gives us 48 volts. So yeah, we can do that. I was talking about this method, determinant method of solving in the previous video, but here I have done it. So basically what I have done, I have written the coefficients in row and like in a determinant form, so row and column. So this is the coefficient of V1, and this column is the coefficient of V1, and this column is the coefficient of I phi, the other unknown. And since I want to find, so this is the denominator, and since I want to find V1, in the numerator will be, instead of V1's coefficients in that column will be the right hand side, and the other unknowns column will be unchanged. So this is as same as the denominator, but this is different, and this is actually right hand side of the equation. So the equation has to be, both the equations have to be written in a standard form, that is a1x plus b1y equals to c1, like that, and then we can just solve the determinant, so we will get the result. So that's 48 volts.